Hello, we can see over here the first question is let A is equal to this value and B is this. B is given as A cube minus A square minus 4A plus 5A. This has been asked in GATE examination 2018 for 1 marks, 2 marks. This is a 2 mark question, very simple question. If you look at this, first of all, just get from the trace the values of A you will get, right? So if you just look at the diagonal elements, lambda 1, lambda 2 value and lambda 3 value is minus 2. You can just look at the diagonal over there. So this is the diagonal value, right? This is the diagonal. So this is my lambda 1, this is my lambda 2 is 2 and lambda 3 is minus 2. Just you need to substitute in the equation for B. For A value, for the first value, you just put for one value. So you see here, it will come 1 cube minus 1 square minus 4 into 1. And remember, identity value is always 1. Plus 5 into 1. So this will come as 1 minus 4 plus 5, right? So 1 and 1, this and this gone. Actually, minus 4 and 5, this will become 1. So for lambda is equal to 1 value, lambda 1, 1, B value is 1. Same way for lambda 2 is equal to 2, B value would be 2 cube minus 2 square minus 4 into 2 plus 5 into 1. So here you see this 2 cube and this value 1. Again it is minus 4 plus 5. Again the value is 1. Same for lambda 3 is equal to minus 2 you put. So this would be minus 2 cube which is minus 8 minus 2 square which is 4 and this would be minus 2 into minus 4 plus 5i. So this is your 8. Okay. And this is your minus 8. So 8 and minus 8 gone and minus 2 square again minus 4 plus 5. So the value happens to be 1. So the determinant of this B value would be 1 comma 1 comma 1. So this is the solution for this question. Now just look at this question. M is 2 cross 2 matrix whose AN values are 4 and 9. Okay, so just use that property. If for A, the AN value is lambda 1, right? For AK, okay, A to the power K, it would be lambda to the power K, right? So lambda to the power K. So since this is a 2 cross 2 matrix, so for 4 the power is, okay, lambda power would be A to the power 2, right? For 4 the value would be 16. Okay, and for the 9 the value would be again A square. For 9 the value would be 81. So the answer to this would be 16 and 81. Just use the properties. Now here this is a question, again it's asked for 2 marks. So this is your P square plus Q square is equal to 1. Okay, given. Now if you look at the determinant of this matrix and if you look at the trace of this matrix, so your lambda 1 value happens to be P, the other root lambda 2 happens to be minus P. If you carefully analyze, lambda 1 is equal to minus lambda 2, correct? This is the thing. And if you go for the determinant, that is cross multiply this would be minus P square minus of Q into Q. So the determinant of this matrix happens to be minus P square minus Q square. Also, you know that determinant is also equal to lambda 1 into lambda 2, right? So lambda 1 into lambda 2 is also equal to minus you take out P square plus Q square, correct? Again, the given condition is P square plus Q square is equal to 1. Use this condition. So lambda 1 into lambda 2 is equal to minus 1, which is also determinant of this, right? Now you just want to calculate the value of lambda 1 and lambda 2. So you have two equations there. Lambda 1 and lambda 2 is equal to minus 1 is given. Okay. And now you have the above equation. So you got this lambda 1 into lambda 2 happens to be minus 1. And also lambda 1 is equal to minus lambda 2. Substitute this value lambda 1 as minus lambda 2, or it would be much better if you substitute the value here. Okay. So just put there. So this is minus lambda 2 into lambda 2 is equal to minus 1. We get the value lambda 2 square happens to be 1. So lambda 2 happens to be root of 1, which is nothing but as 1. So therefore lambda 1 happens to be minus 1 because lambda 1 is equal to minus lambda 2. So you got the solution. 1 and minus 1 is the answer for this question. Okay. So we will stop the recording.